Now, equation of the plane progressive wave. Now, generally this equation is y is equal to a sine omega t, where a is the displacement amplitude and omega is the angular, that is the phase angle. But sometimes we write this equation in terms of phase. Phase means the position and direction of the particle at any instant of time, and it is indicated by phi. But at the same time, there is a definition phase difference, that is 2 pi x over lambda. So now for equation of wave or plane progressive wave in terms of equation, that will be y is equal to a sine omega t plus minus phi. We put the plus sign if the wave is moving in the positive, that is in the negative direction of x-axis, and we put a negative sign when the wave is moving in the positive direction of x-axis. If on the propagation of wave in a medium, the particles of medium perform simple harmonic motion, that is SHM, then the wave is called simple harmonic progressive wave. Suppose a simple harmonic progressive wave is advancing in a medium along the positive direction of x-axis. The meaning of this is that if it is positive direction, wave is coming from the negative side, that is from negative x-axis towards the positive x-axis, that is from left to right. The normal Cartesian coordinates are plus to the right, minus to the left, positive height and negative depth. Now in figure A, equilibrium position of the particles or the mean positions are indicated by 1, 2 and 3 as shown. When the wave propagates, these particles oscillate about their mean positions, as in figure B. The instantaneous position of these particles at a particular instant are shown. The curve joining these positions represent the wave. Let the time be counted from instant when the particle, one situated at the origin, starts oscillating. If y is displacement, then after t seconds, equation will be y is equal to a sine omega t. Omega t is the phase angle and a is the displacement amplitude, y is the displacement. So this I have already explained, that is amplitude, omega is 2 pi n, and is frequency. Now here in the figure, a plane progressive wave is shown and dark dots are maintained. They are the positions of the particle. Now when we see the particle number 3 and particle number 7, we find that there is a straight line and there is a curve. So 3 and 7, these points on the curve indicate antinodes. Antinode is a point of maximum displacement and minimum velocity. And the points 1, 5, 9, etc. These points are indicating the node position, and node is a point of minimum displacement and maximum velocity. And the direction is indicated towards x-axis. As the wave reaches the particle beyond the particle 1, the particles start oscillating. If the speed of the wave be v, then it will reach particle number 6, distance x from the particle 1, and that distance is given as x over v, or the time is given as x over v, where x is the distance and v is the speed, and this time is calculated in seconds. So all this explanation is valid for all other particles, that is, the other particle or the next particle oscillate after some time, and that time is x over v. Therefore, the particle 6 will start oscillating x over v seconds after the particle 1. It means that displacement of the particle at 6 at time t will be the same as that of particle 1 at time x over n seconds earlier. So at time t, that is x over v, the displacement of the particle 1 at time t is equal to x over v can be of the particle 6, distance x from the origin, that is particle 1 at time t is given by. Now time t is given by, now main equation is y is equal to a sine omega t plus phi, but phi can be replaced by 2 pi x over lambda, and lambda will be replaced by vt, and then we put in the general equation and we come to conclusion that y is equal to a sine into t minus x over v, but omega is 2 pi n. So that we can put here. So a sine omega t minus kx, and k is taken as omega over v. Omega is 2 pi by t or 2 pi n. So we have modified these equations, and negative sign indicates that wave is propagating in the positive direction of x-axis, and k can always be replaced by 2 pi by lambda. So equations are y is equal to a sine 2 pi small t over capital T minus 2 pi by lambda. We have substituted this value 2 pi by lambda for k and multiplied by x. So this whole equation will become a sine 2 pi t over t minus x over lambda. So this is the equation of SHM in terms of path difference and phase difference. This is the equation of simple harmonic wave traveling along positive direction of x-axis because phase is taken as negative. If the wave is traveling along minus x direction, then inside the brackets in the above equation, then instead of minus sign, there will be a plus sign if it is moving in the negative direction of x-axis. For example, equation number 2 will be of the following form. Y is equal to a sine 2 pi t over t plus x over lambda. We have written the positive sign. It means wave is moving in the negative direction of x-axis. That is from O origin towards x dash. Now phi, this symbol stands for phase difference or simply position and direction of the particle. The phase difference is given by function 2 pi x over lambda, and lambda is indicated by Vt, velocity into time period. So the main context is if phi is the phase difference between the above wave traveling along x-axis, another wave, then equation of that wave will be. Now equation is given. This we have modified from equation, that is a is equal to y is equal to a sine omega t minus phi. However, instead of taking the sine function, we can also take the cosine functions, because general equation of SHM can be a sine function or a cosine function. However, we are considering all equations in terms of sine function. Well, now the equation of wave is y is equal to a sine omega t minus phi, but phi is taken as kx and k is taken as 2 pi by lambda. So the whole number will become 2 pi x over lambda. So velocity of the particle, we take the derivative of the number, that is derivative of the displacement. So we take dy over dt, derivative of y with respect to time. So we take derivative of a sine omega t minus ky, that becomes a omega cos omega t minus kx. You will remember that derivative of sine function is a cosine function. So we have written a cosine function. Wherever we write omega, that is 2 pi by t or 2 pi n, and a omega is called the velocity amplitude. Again, the value of k is taken as 2 pi by lambda or 2 pi x over lambda. Slope of the wave is given as derivative of y with respect to time, and if we take y and we take the derivative, then after taking the derivative, the number becomes ak cos omega t minus kx. Now we have two equations, number 3 and 4. Dividing equation number 3 by 4, we find a will cancel off and cos omega t minus kx will also cancel off, and we will get only omega over k. Well, k will be 2 pi by lambda. So this is indicated now, and we have calculated this value as minus omega over k into dy over dx. dy by dt will be minus v into dy by dx. That is, dy by dt is the velocity of particle is equal to minus of the velocity of wave multiplied by slope of the wave. Dy by dx is called the slope of the wave.